Find the derivative of the plane curve defined by the given parametric equations in terms of the parameter. Here we have parametric equations x equals t plus 1 over t, y equals t minus 1 over t. So our parameter here is t. Both x and y are given in terms of t. And we recall that the derivative of y with respect to x, that's the derivative of the plane curve, is equal to the derivative of y with respect to t divided by the derivative of x with respect to t. In this way, we can find the derivative directly from the set of parametric equations that we're given. Okay, so let's go to the side here and do a little bit of work. We've got x equals t plus 1 over t. And we want to find dx dt, for instance. We're going to need that. Well, we can rewrite this, x equals t plus t to the negative 1. Remember, 1 divided by t is equal to t to the negative 1. This makes our derivative pretty easy to find. The derivative of t is 1, plus the derivative of t to the negative 1 is negative 1 t to the negative 2. Simplifying, we get 1 minus 1 over t squared. Or if we combine these two terms together, 1 is the same as t squared divided by t squared if we multiply the top and the bottom by t squared. So we end up with t squared minus 1 divided by t squared. That is the derivative of x with respect to t. Similarly, we can find the derivative of y with respect to t. We know that y is equal to t minus 1 over t. That's given in the problem. So here y is equal to t minus t to the negative 1. And when we find dy dt, we have 1 plus 1 over t squared. Very similar to what we did above. And combining those terms together, we get dy dt is t squared plus 1 divided by t squared. Using these two, dy dt and dx dt, here's our dx dt, we know that our derivative, dy dx, is equal to dy dt, that's t squared plus 1 divided by t squared, divided by dx dt, which is t squared minus 1 divided by t squared. To divide fractions, remember you multiply by the reciprocal of the denominator, so t plus 1 divided by t squared times t squared divided by t squared minus 1. In this case, the t squareds cancel. So we finish with the derivative of y with respect to x is equal to t squared plus 1 divided by t squared minus 1. And we may think that we can, factor some things, but unfortunately t squared plus 1 does not factor over the real numbers. And so we're simply left with our derivative of y with respect to x being t squared plus 1 divided by t squared minus 1.